Hello, geometry class. This is your homework this evening to watch a video on perimeter, circumference, and area. Let's just do some quick review. Perimeter is the distance around a figure. You might remember that from elementary school. For example, if I had a rectangular shaped yard and I wanted to build a fence around it, you'll need to calculate how much fencing you need by adding up all four sides. Okay, so that's essentially perimeter. The formula for the perimeter of a rectangle is two bases plus two heights. Same thing works with a square, except your base is your height, so it'll be two sides and two tops and bottoms, or a total of four sides. So that's perimeter in a nutshell. Now you may end up with another type of object such as a circle, and the perimeter of a circle has a special name that's called circumference. And the formula for the circumference of a circle is 2 times pi times the radius, or pi times the diameter. I want to remind you that diameter is all the way across. Radius is just from the center of a circle to an outer edge. And pi is 3.14. That's an estimate of pi. Sometimes you'll see 22/7 as a fractional. Okay, so that's perimeter. We talked about perimeter of a rectangle or square. We talked about the perimeter of a circle, which is called circumference. If you need to pause the video, feel free to do so. Otherwise, this video will play on. The next thing we're going to talk about is the area. We alluded to the area of these figures in this class before. So here goes a rectangle, and here goes a circle. Essentially, we have a length and we have a width, and on our circle we have a radius and we have a diameter. So the area of a rectangle is just your length times your width. If you have a square, it's just your side squared. You can write rectangle there. And the area of a circle is going to be pi times your radius squared. That's area. What we're going to do now is do a couple of example problems, one for perimeter and one for area. So here goes the example problem for perimeter. Let's say you do have a rectangular shaped swimming pool, and let's say you want to build, or you have a sidewalk going around that swimming pool, and the length of your pool is 20 feet. And the length of your sidewalk is 3 feet. Your swimming pool is 15 feet wide, and it's a 3-foot walkway all the way around. So what you need to do, and there's a picture, what you need to do is calculate the perimeter of your fence going around the decking. So you need the total length and you need the total width, and then you need to add all that up. So my total length is going to be the length of my pool plus 3 feet on the top and 3 feet on the bottom. So that's 26 altogether long. My width, okay, is 15 feet for the pool, and then I also have 3 feet on either side for the walkway. That's 21 feet altogether. Now I said that the perimeter is going to be 2 lengths plus 2 widths. So that's 2 times 26 plus 2 times 21. 2 times 26 is 52, and 2 times 21 is 42. So altogether, you need 94 feet of fencing to go all the way around that rectangle. The same type of problem can be done for a circle, except in the circles you're just using a different formula. That's pi times your diameter for the circumference. Alright, if you need to copy that down, go ahead and pause the video, otherwise the video will play on. Here goes a second example, but this time instead of talking about perimeter, we are going to talk about area. Now we're not going to do a boring problem where it essentially says that length times width is area, because you've done that. You've practiced those problems before. Before we proceed, I'd like to talk about 2 more postulates. Postulate 1-9. It says if 2 figures are congruent, in other words, if one is equal shape and size to the other, then their areas are congruent. There's a postulate. Are equal to each other. And then another postulate is 1-10. And that says the area of a region is the sum of the areas of its non-overlapping parts. For this last one, it essentially says if I have a figure and I take that figure and cut it up into a bunch of pieces that don't overlap, I essentially need to add each of those different pieces together, 3, 4, 5, 6, in order to get the total area of the figure. Now we're going to use that postulate in this example. So in this example, I have a figure, and this figure looks like this. Looks like a set of stairs. And on this figure, I'm saying that this distance is 6 centimeters. And I'm saying this distance is equal to that distance. I'm saying that this distance is 2 centimeters, which is equal to each of these steps. And I want to find the total area. There's several different ways to do this. Let's start off with this first one. What I could do is to take the figure and split it out into different parts. One way to do that is to just draw a couple of horizontal lines. So I have this top section, I have this middle section, and then I have this bottom section. So let's start off with that top section. Let's find the area of that, and then we're going to find the area of our middle section, and then we're going to find the area of our bottom section, and then we're just going to add all three together. So looking at the figure, I know that this is 2 and that's 2, and the area of that is 2 times 2. So the area is 4 centimeters squared for the top box. The middle box, it's 2 plus another set of 2 across. That makes this 4. And my height is 2, so 4 times 2 is 8. And looking at the purple section, I know it's 6 by 2. That's 12. If I just add all that up, I get 24 centimeters squared, and that gives me the total area of that figure. Okay. If you need more time to copy that down, please go ahead and do so. Otherwise, this video will play on. The next thing I want you to do is to please take out a blank sheet of paper, please. On this blank sheet of paper, I want you to do this one problem. Please find the area of the shaded area region. Use the skills I just taught you, that I just reminded you, to find the area of the shaded region. So what I'm going to do here is, first of all, draw a rectangle. And inside the rectangle, I'm going to draw a square. Oops. Okay, this is not necessarily drawn to scale. And what I'm going to do is I'm going to label. I'm going to say this distance right here is 4 inches. And I'm going to say it's a square. So this side is equal to that side. I'm going to say that the overall height is 8 inches. And the overall length is 12 inches. And the shaded region that I would like you to calculate for me the area of is going to be everywhere except for the square on the inside. So there's several different ways to go about this. I'd like you to use your geometry and algebra skills to calculate that area, and then that one problem is due tomorrow for homework. Alright, class. Thanks for watching the video. I appreciate that. I'll see you when I see you.